This video will be solving this problem. Here in the question, they have asked find out what are the forces in G3 and G2. What are the weights of G2 and G3? This is a weight is there are two pillars. We have which has been connected to the three weights here in this arrangement. To start with, let us consider this joint. Why this joint? Why not other joints? Is so here we don't know what is S1, what is S2. These are the forces in this row. Right? Now we have this weight which is connected here. With this weight, we can find out what is my S1 and S2. Then, after we have found out this, we can easily find out what is my G2 and G3. To start with, let me draw the free body diagram at the joint. So this is my joint row. I have a load acting downwards, which is of 10 kilonewton. Then I have this force S2, and I have S1, which are making an inclination of 60 degrees here. S2 is making 60 degrees with S1 is making 30 degrees with horizontal. Now, first of all, I need to resolve these forces. So when I resolve this, so S2 will the horizontal component S2 cos 60 degrees and vertical component S2 sin 60 degrees. Similarly, if I resolve this S1 component, so I have this S1 cos 30 degrees. The vertical component will be S1 sin 30 degrees. Once I have drawn the free body diagram and resolved it, next step is to solve the problem. Apply the equilibrium equations. We know that summation H equals to 0. All the horizontal forces are equal to 0. So I have this S1 cos 30 degrees acting left side, it's negative. S2 cos 60 degrees acting right side, positive, that is equals to 0. I can write this one as S1 equals to S2 cos 60 degrees cos 30 degrees. Now let us apply the second equilibrium equation, that is summation V equals to 0. So all the vertical forces are equal to 0. So I have this S1 sin 30 degrees plus S2 sin 60 degrees. Since these both forces are acting inwards, so positive, minus 10, which is 10 kilonewton, which is acting downward, so negative, equals to 0. In this, I am substituting S1 value, so I will get S2 cos 60 degrees sin 30 degrees over cos 30 degrees plus S2 sin 60 degrees minus 10 equals to 0. Solving this, we'll get S2 value equals to 8.66 kilonewton. So this is my S2. Now substituting this S2 value in S1, then I'll get S1 equals to around 5 kilonewton. So I got my value of S1 and S2 forces table. Now let us do this joint. Let us call this one as B. This one joint is called. Let us draw the free body diagram of these two forces. So now I have this, let us consider joint B. From the joint B, I have this force acting, which is vertical. So I have this force which is joining This is my 2. G2 is acting downwards, which is unknown, and I have this S2, which is 60 degrees. I'm drawing this S2. So since opposite inclinations are same, this is making 60 degrees, so this will also be 60 degrees. Hence, I'm resolving this force. This is my S2. So horizontal component will be S2 cos 60, and downward component will be S2 sine 60 degrees. We already know what is my S2. So I'm applying this. Let us consider we don't know the direction of this G2. Let us consider it is acting downwards. Now G2 plus S2 sine 60 degrees equals to 0. I'm applying summation P equals to 0. When I apply this, I'll get G2 value as 8.66. So this is my G2 value. Similarly, I need to do it for joint. This is my joint. Let me do it for joint here. Joint A. You see a joint A, this G3 is not vertical, it is inclined, which is making inclination of 80 degrees. Similarly, this is my G3, which is making an inclination of 80 degrees. This is also 80 degrees. If I draw the resolve it, this will become G3 cos 80 degree. The vertical component. The vertical component will be G3 sine 80 degrees. Similarly, I have this force S1, which is making 30 degrees. When I resolve this vertically, I'll get S2, S1 sine 30 degrees, and this will become S1 cos 30 degrees. When I apply summation at h equals to 0, I'll get G3 cos 80 degrees equals to S1 cos 30 degrees. From this, P will be equals to 5.8. This is how you need to solve this problem. Thank you.